Okay, so welcome back for a little bonus information. So this is not something that you need to know for a test or quiz, but I always like to know, where do these formulas come from? Like, how did we come up with this based on the concept of arithmetic sequence and a common difference. So I'm just going to try to explain to you one way to come up with this result, all right, for the nth partial sum of an arithmetic sequence. Okay, so just to rewrite that, well, actually, we can just use a new sheet of paper. So just take a blank sheet. So we have n divided by 2, a sub 1 plus a sub n gives gives the nth partial sum of an arithmetic sequence with common difference d. Okay, so we're working with a few things. We're working with arithmetic sequences, and we're working with the fact that they have this common difference that we call d. Okay, so the way to come up with this formula, or one way, is let's just explicitly list what is the sum of n terms. Okay, and let's just write this in terms of a sub 1 plus a common difference. So we can write this as, well, the first term is a sub 1, and from finding the nth term, we know that we add this common difference to each consecutive term. Okay, so the next term is going to be, and I'm going to use brackets here, the first term plus d, the common difference. Now, the third term is going to be the second term, which is a sub 1 plus d plus another d. Okay, right, so that's 2d plus, and then the third term is going to be a sub 1 plus 3d uh, plus dot 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 all the way down to, well, we'd have a sub 1 plus n minus 2 times d plus a sub 1 plus n minus 1 times d. Okay, so if we added up all of these terms, we would get s sub n. All right, now the key to coming up with this formula using this method is to write s sub n in a different manner. Okay, another way we can do it is, instead of starting with the first term, a sub 1, we'll start with the nth term, and let's call that a sub n. Okay, so how would we get the nth minus 1 term? Well, we'd have to add to that, because we're looking for a sum. Well, we'll take a sub n and we're going to subtract d from it, and that's going to give us a sub n minus 1. So then to that, we're going to add the nth term, a sub n, and we're going to subtract from that 2d. That would give us the nth minus 2 term. And this pattern will continue all the way up to, well, we're going to have the a sub nth term, and then we're going to subtract from that n minus 2 times d. Okay, now our last term that we'll have is n minus 1 a sub n minus 1 times d. Now we've come up with these two separate ways to represent s sub n. Now I'm just going to use the commutative property, okay, because this is all addition, right? And I'm summing in terms. So here's the first term, here's the second term, here's the third term, all the way up to the nth term. And each of these terms has a sub 1 in it. So if I were to write all of my a sub 1s next to each other, essentially, I would have a sub 1 plus a sub 1 plus dot 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 plus a sub 1, and this would be a sub 1 n times, okay, addition. So this would be a sub 1, and then I have plus all of these d's. Well, I'd have, whatever is left would be d plus 2d plus 3d plus dot 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 plus n minus 1d. Okay, so I can rewrite that in this manner. Now for s sub n written in terms of a sub n, I'll do the same thing. I'll bring all of my a sub n's to the front. So I have a sub n plus a sub n plus dot 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 plus a sub n, another n times because I'm summing up n terms. And then what's left? Well, I have minus d minus 2d minus 3d included in this, all the way up to minus n minus 1d. Okay, so I'm looking at these patterns and I'm wondering what would happen if let's say I subtracted these two things. Actually, I'm going to add them. Let's add them. Okay, well, if I add them, my left hand side, I have s sub n plus s sub n. That's going to be 2 s sub n. Okay, on my right hand side, well, I have a1, a sub 1 n times, which I can write as n times a sub 1, right? Because I have a sub 1 n times, that's n times a sub 1. And then on this part here, I can add to that, well, I have a sub n n times, so that's going to be n times a sub n. And when I add this part with this part, well, what's going to happen? I'm going to have plus d minus d, plus 2d minus 2d. So here, cancel, cancel, plus 2d minus 2d, cancel, plus 3d minus 3d, all the way up to plus n minus 1d minus n minus 1d. All of these terms involving my common difference cancel. They're gone. And this is what I'm left with. All right, this is very useful, and we're almost done. All we want to do is just make this look like our original formula, which is this. Okay. Now, in order to do that, well, we need to solve for the sum, which is s sub n. So all we're going to do is just divide both sides by 2. So s sub n equals n a1 plus n a sub n divided by 2. All right. So, but you're saying this is not the same as that. And I'm saying that this is the same as that. All we have to do is factor out the n from the denominator or from the numerator. So we do that, we get n a sub 1 plus a sub n divided by 2, which equals our formula, n divided by 2 a sub 1 plus a sub n. That's not a factorial symbol. That's just, hooray, we did it. Thanks for watching.